Hello everyone, and welcome back to the now second video here in our review for the Inference for Proportions section of your AP exam. This video today is going to cover specifically two proportion Z intervals. We're going to talk about the difference between a one proportion and a two proportion, which is not very much. And we're going to look at the mechanics and some types of questions that you might see. So, without further ado, let's jump right into it. So, what's the biggest difference with two proportions when we look at our acronym, right? For P in panic. What you're looking at here is it's now going to be the true difference in proportions. Again, fill in the context. So instead of just estimating one proportion, we're estimating the difference in proportions. For my assumptions, it now needs to be true for both samples instead of one sample. So both samples need to be random. Both samples need to be large enough. For my numbers, I'm just going to now list the numbers from both samples. And my confidence level, that doesn't change. For the interval, it's now a two proportion Z interval. But my conclusion stays the same. What's really important for your conclusion is we're looking for the number 0. If 0 is in your interval, we don't have evidence of a difference. But if 0 is outside of your interval, then we do have evidence of a difference. And that is one very important thing. And so let's take a look at an example problem. Right? And so for this particular one, it's a day shift and a night shift. I have two very specific independent samples, right? And we believe that there is a difference. And so, and does it say here we have random samples of parts? Great. And we've got 188 out of 200 and 180 out of 200, right? And so for this one, it's a 96% confidence interval. So when I look at part A, I'm going to use some subscripts that matter here in the context of the problem. D for day shift, N for night shift. So this is the true difference in the proportion of defective parts between the day and night shift. Great. For my assumptions, right, so this is P. One, I need to have both samples that are random. And I know that that's true because the problem says so. Right? The problem says that random samples were taken. Now again, you should quote that in your response. For my large enough, in this particular case, what I like to do is make myself a table. I've got day shift, I've got night shift, and then we have like okay and defective. Now, if I look here, the okay for the day shift was 188, which means, oops, wrong place, which means the 12 here. And then for the night shift, it was 180, so this is 20. All these are greater than or equal to 10, so I can move on. My numbers is an optional step here. So I'm going to jump straight to the interval, which is a two proportion Z interval. And then using my calculator, right, I can put in my numbers here, and it was a 96% confidence interval. And I get an interval of negative 0.0156 to 0.0956. Biggest thing here, what am I looking for? I'm looking for 0 to be a part of that interval. And so because 0 is here, we have no evidence of a difference. Because 0 is there, I don't have evidence that the day shift or night shift produces fewer or more defective parts. If this interval was all positive or all negative, then I would have evidence. But because 0 is there, I don't have evidence of that at all. And so that's your part B of, based on this confidence interval, do you think that the difference in proportion of parts produced is different from 0? No, I don't, because 0 is in my interval. So that is your biggest difference when it comes to one proportion versus two proportion. You're looking at estimating a single parameter versus estimating the difference in parameters. So I hope that was helpful, and I'll see you guys in the next one where we talk about hypothesis tests.